Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to start a new topic, new chapter, which is correlation and simple linear regression. So in correlation, basically, correlation and simple regression, basically, we want to find relationship between two variables. So when we want to find the relationship between two variables, then the appropriate technique is to use correlation analysis. So correlation analysis is a statistical technique used to measure the relationship and the strength of relationship between two variables. So these two variables commonly known as independent variable and dependent variable. Right? So it is known as independent variable and dependent variable. So independent variable, normally we put at x-axis. So this is x-axis and this is y-axis. So y is dependent variable. When we draw a graph, right, to indicate the relationship between two variables, the independent variable normally at x-axis and dependent variable should be on y-axis. Dependent variable. And this is independent variable. Right? So, for example, let's look at two variables such as sales and profit. Right? So, let's say we have two variables, sales and profit. So basically, we would say that sales would determine the profit, right? So sales akan determine the profit. So in this case, profit depend on sales. So profit is dependent variable and sales is independent variable, right? So this is the example of independent variable and dependent variable. So you need to be clear to justify which variable should be independent and which variable should be independent. Right, let's look at another example, the production cost and the production unit. So we will say that the production cost will depend on the production unit. So the production cost is dependent variable and the production unit is independent variable, right? So another example is, let's say, smoking can cause heart disease, right? So smoking depend on heart disease, or heart disease depend on how many cigarettes you smoke. So heart disease depend on how many cigarettes you smoke. So heart disease is dependent variable and how many cigarettes you smoke is independent variable. So this is a very important step to find relationship between two variables, right? You need to identify which variable is dependent variable and which variable is independent variable. So there are methods to determine correlation between two variables, right? So the first method that we're going to learn is scatter diagram or scatter plot. And the second method is Pearson product moment coefficient of correlation. So the third method that can be used to determine correlation between two variables is a Spearman rank coefficient of correlation. Right? So there are commonly known three methods that can be used to identify correlation between two variables or relationship between two variables. Either the relationship is positive relationship or negative relationship or no relationship at all. Right? In this case, in our topic, we are discussing on linear correlation. Right? So we are looking into linear correlation. So we are going to look at how the two variables correlate in linearly, right? Either upward or downward, right? If we have other pattern than linear pattern, then we will not consider in our topic, right? Because we are only looking into linear correlation or linear relationship. So as I said just now, we have three methods to determine correlation between two variables. The first method is scatter diagram. So scatter diagram, normally we should draw a diagram. We should have axis, which is y-axis and x-axis, right? So y-axis is your dependent variable, and x-axis is independent variable, right? So normally we will plot the data observation into the diagram just scatteredly. So we will see whether the trend is upward or downward. So if the trend is upward, then we say that the relationship or correlation between two variables is positive. If the trend is downward, so we can say the relationship between two variables or correlation between two variables is negatively relationship, right? So let's look at the first method, which is a scatter plot or scatter diagram. So scatter plot or scatter diagram is a graph that shows relationship between independent variable and dependent variables. So it's also known as scattered plot, right? By drawing scatter diagram, we can determine the type of correlation between independent variable and dependent variable, whether it has a positive correlation or negative correlation or no correlation at all. So now look at the type of correlation by scatter diagram. So if you have this type of graph where the observation are perfectly perfectly oriented on the straight line, right? This is very rare to get. So this is what we call as perfect linear positive correlation, right? When we see the trend is upward, right? So the perfect linear positive correlation indicate that variable x increase, variable y also increase. When the variable x increase, y also increase, right? So let's say this one is number of cigarette smoke. This is heart disease, so risk of heart disease, right? So when you smoke more cigarette, so the risk of getting heart disease also increase, right? So this is what perfect linear positive correlation all about, right? So another type of scatter diagram, which is this type. So the data are scattered, but we can see the trend is upward, right? It is a upward trend. It's increasing from the left to right. So this is also what we call as a linear positive correlation. So as long as it show a linear shape of a trend, so we can say that is a linear correlation. So whether they're upward or downward, so we can say if the graph is upward, so we can say that it has a positive correlation. If the trend is downward, so we can say that the trend the correlation is negative. So look at another graph. This is another example, right? So this is when you have a downward trend. So this is a perfect, the data are aligned in a perfect line, right? So this is, we say that it has a perfect linear negative correlation. So this is having a perfect linear negative correlation. So a perfect linear negative correlation or negative correlation says that when x increase, y will decrease, right? When the independent variable increase, the y variable or dependent variable will decrease. So this is how we interpret the correlation, the negative correlation. So of course the negative correlation you will see like this. So it will scatter and then we will get a straight line. It will scatter around a straight line, right? So a straight line means a linear. So when the trend is downward, so we call as a linear negative correlation, right? So when we see a non-linear correlation, so we can see the quadratic shape. So this doesn't mean no correlation, but it has a correlation. The first half is positive correlation, the second half is negative correlation. But this is a non-linear correlation. This is not our interest in this topic. We are interested to study linear correlation only in this topic, right? So the trend, when you have a scatter diagram like this, it shows that there are no correlation because there are no shape, whether upward or downward, right? So this is what we call as a no correlation between two variables, right? So so far, are you okay? Do you have any question? Or are you clear with my explanation? Can you comment on the chat box? Clear, right? So if you clear, then we can move to another method, which is Pearson product moment coefficient. But before we go to this method, let's do some example. Right, let's look at example number 49. So this is example number 49. So I want you to take out your graph paper and let's do it together, right? So in example number 49, right, a marketing officer in a company wants to know the relationship between annual advertising expenditure and annual sales of the company. So for the study, he collected the data on advertising expenditure and annual sales of the company for the last 8 years. So we have 8 years. This is 8 data. 1, 2, 3, 4, 5, 6, 7, 8. Right now, the first part that we need to identify is what is the independent variable and what is dependent variable. So we need to ask ourselves, advertising expenditure depend on annual sales or annual sales depend on advertising expenditure? Can you give me some answer? Can you give me some answer? Advertising expenditure depend on annual sales or sales depend on expenditure?
Annual sales depend on advertising expenditures.
Sorry?
Annual sales depend on advertising expenditures.
Yeah. So when annual sales depend on expenditure, right? Advertising expenditure means annual sales is dependent variable, right? And annual advertising expenditure is independent variable, right? So this is the most important step, right? If you fail to identify which variable is dependent and which variable is independent, then when we do a simple linear regression, you will get a wrong answer, right? So we will get the right answer on the Pearson product moment correlation, but in simple linear regression, you will get a wrong answer, right? So this is the most important step, right? You need to identify which variable is independent variable and which variable is dependent variable. So question number 2, draw a scatter diagram to show relationship between variables and what conclusion can be made, right? Can you take out your graph paper and try to plot this graph? Okay, let me draw. So first we need to have x-axis and y-axis, right? So this one, y-axis is dependent variable. Dependent variable is annual sales, right? And then x-axis is independent variable. Independent variable is annual advertising expenditure, right? So this one, for annual sales, the largest number is 8. So let's say 1, 2, 3, 4, 5, 6, 7, 8. This is 1 million, 2, 3, 4, 5, 6, 7, and 8. And this is 1, 2, 3, 4, 5. Let's say 1, 2, 3, 4, 5. Right? So when the first one, when annual advertising is 2 million, the annual sales is 5 million. So we just plot this point. When x equal to 1, y equal to 3. X equal to 4, y equal to 6. And then x equal to 3, y equal to 5. X equal to 2, y equal to 4. X equal to 4, y equal to 7. X equal to 5, y equal to 8. And x equal to 3, y equal to 6. So don't forget to write down your title. This is a scatter plot showing annual sales and showing relationship between annual sales and annual advertising expenditure, right? And capital N equal to 8. So this is how we draw a scatter diagram. Of course, you need to draw in your graph paper lah, right? To get a nice view of the data. So based on the scatter diagram, we can see that the trend is upward, right? The trend is upward. So we can say annual sales and annual advertising expenditure has a positive linear correlation. So it has a positive linear correlation, right? So this is the conclusion that we can make from the diagram. So we can see the data is upward from the left to right. So this is a positive correlation, right? So we can say annual sales and annual advertising expenditure has a positive linear correlation. So this is how we determine the relationship between two variables, right? So far, are you okay? Do you have any question on how to uh, construct a scatter diagram and how to interpret the scatter diagram? Do you have any question? You can comment on chat box. Right. Right, good. So we're going to move on the next topic, which is the next method, which is a Pearson product moment coefficient of correlation. Right. So in this method, right, instead of scatter diagram, let's say, I just want to differentiate between a Pearson product moment coefficient and correlation and scatter diagram. In scatter diagram, we can only know the relationship between two variables. Either the relationship is positive or negative, or no relationship at all, right? But in Pearson product moment coefficient of correlation, we can know, of course, we can know the relationship, whether positive correlation or negative correlation. And we also can know the strength of correlation. Either the correlation is strong, moderate, weak, or no correlated, right? So in this coefficient of correlation measure relationship between two variable and the strength of degree of correlation, right? Strength of correlation can be either perfectly correlated, strongly correlated, moderately strong correlated, and then weakly correlated, or no, not correlated. So the symbol for Pearson product moment coefficient of correlation is R, right? So we're going to use R to represent Pearson product moment coefficient of correlation. So the formula, let's use this formula, right? So summation of xy, right? Again, you need to identify the dependent variable and independent variable. And remember, dependent variable is y, independent variable is x, right? So xy minus summation of x multiplied with summation of y divided by n, right? Everything divided by the surd, you take the surd, the square root, right? The first part is summation of x squared minus summation of x, and then you squared, divide by n, and then multiply with summation of y squared minus summation of y, and then you square, divide by n. And don't forget the square root. This is the square root for the whole thing, right? For the whole denominator. And you need to remember, in this formula, summation of x squared is not equal to summation of x, then you square, right? And of course, summation of xy is not equal to summation of x multiplied with summation of y. So it's totally different value, right? So this is R, right? So we're going to focus on the second formula. You can use also this first formula, right? It's the same formula actually, right? So the value of R, this value of R can take range from -1 to +1. It can be either from -1 to 1, right? So when R is equal to 1, when R is equal to +1, so we can say that there is a perfect linear positive correlation between X and Y. When X between 0 and +1, means there is a linear positive correlation. Means when R is a positive value, then it's a positive correlation or linear positive correlation. When R is given negative value, right, from -1 to 0, so there is a linear negative correlation, right? When R is equal to 0, then we can say that there are no linear correlation. So this is very easy to remember, right? So when R is positive, means positive correlation, right? This is a linear positive correlation. When R is equal to negative, means linear negative correlation, right? When R is equal to 0, means no correlation, right? So the strength of correlation, right? We can divide the strength of correlation. So when R is equal to 1, when you get the value of R exactly equal to 1, we can say that perfect correlation with disregard negative, right? When R is equal to -1 or R is equal to 1, so we can say that perfect correlation, right? So perfect kalau dia dapat 1, perfect positive correlation. When we get negative 1, perfect negative correlation. So remember again, when R is equal to 1, right? Either negative 1 or 1, right? We can say that it has a perfect correlation. When R is equal to 1, means perfect positive correlation. When R is equal to negative 1, perfect negative correlation. Right? When R is between 1 and 0.75, right? 0.75 to less than 1. So means that you see 0.75 is included, 1 is not included. So we can say that it has a strong correlation. So either negative or positive, right? When you have a positive value 0.85, let's say for example example 0.85, right? So it means that this value, the variable have a strong positive correlation. And when you get negative 0. Let's say 79, so we can say that the two variable has a strong negative correlation, right? So another one, let's say from 0.5 until 0.75, 0.75 is not included, 0.5 included. So we can say that we have a moderately strong, right? Same as before. So when we have negative value, is a negative moderately strong negative correlation. When you have a positive value, moderately strong positive correlation, right? When the value of R is between 0.0 and 0.5, means that 0 and 0.5 is not included, right? It's not included. So it has a weak correlation, right? Disregard the negative sign, right? When you have a negative value, weak negative correlation. When you have a positive value, weak positive correlation. When R is exactly equal to 0, right? So there are no linear correlation at all, right? So now look at this example. When you have R is equal to 0.97, it means that the two variable has a strong negative correlation, right? Strong linear negative correlation between X and Y, right? Okay, do you understand my explanation? This is very important. If you don't understand this, then the interpretation is going to be very wrong. Can you comment? Alright, good. So now let's look at example number 49. We try to calculate Pearson product moment coefficient of correlation, and we're going to explain the meaning. But see, in this example, we want to do question number 3. Right? In this example, we already construct a scatter diagram, and we know that from the scatter diagram, it has a positive linear correlation, right? So of course, when we calculate the Pearson product moment coefficient, it should lead the same result. It should conclude positive correlation. But by calculating Pearson product moment coefficient, we can know the strength of correlation, right? So now let's jot down the equation. So R is equal to summation of xy minus summation of x multiplied with summation of y divided by n, then everything divided by square root of this. The first part is summation of x square minus summation of x and then square divided by n, and the second part is summation of y squared minus summation of y and then you square divided by n. And don't forget, this is having a square root for all denominator, right? So of course we have, this is our x and this is our y, right? Let me clear some this. So this is our x and this is our y, right? So of course we need to expand the table to calculate x, y, summation of x, summation of y. But in my class you don't need to do that, right? So let me use the calculator. Let me stop sharing first. Right. So now you can see my calculator, right? You can see my calculator. Right. So now we need to identify which one is x variable and which one is y variable. So by using the calculator, first you need to clear all the memory. Right, click shift 9 3. Clear all the memory equal AC. Right. So the second step is you need to click on mode. Right. Click on mode, find statistic number 3. Right. Now last time we used 1 minus variance, right? The first one. Now we're going to use the second one, a plus bx. A plus bx. So click number 2. So it will appear like this, right? So the first column is x, the second column is y. So you need to careful. Sometimes in your question, the first column is y, the second column is x. So you need to input the data carefully, right, into the correct column. So the first one is 2, 1, 4. This is 3, 2, 4, 5, 3. So we have 8, right? So next, begin to input the y. 5, 3, 6, 5, 4, 7, 8, and 6. Right? So by using this calculator, you can recheck your data imputation, whether you correctly input the data, right? Let's assume we already input the data correctly. So we click on AC, right? So now we want to find the value of summation of xy, summation of x, summation of y, and then summation of y squared, summation of x squared, and the last one is n. And n also we already know n is equal to 8 lah. Right, let me use the darker color. Right. So let's say the summation of xy, summation of x, summation of y, and the summation of y squared, x squared, and n. N is equal to 8. Right. So next step, we click on shift 1 for stat. You can see stat here, 1. And then click on sum. We want to find sum, number 3. Right? So this is all the value we have. xy is number 5. xy is equal to 146. So this is 146. Summation of x, number 3. X is 2. So 24. Summation of y, same process. Summation of y is number 4, is equal to 44. Y squared, number 3 is 260. And x squared is number 1, 84. Right. So you need to remember in your test or final exam, right, you need to write down as what I showing to you, right? I don't want you to give me the final answer. If you give me the final answer, let's say R is equal to 0 point something, without plug in this value into the formula, you will get 0, right? So I want you to show me R, you need to plug in the value into the formula. So this is 146 minus, this is 24, multiply with 44, right? Divide by 8. Everything divided by the square root of the first part is summation of x squared 84 minus this is 24 squared over 8, right? Multiply with 260 minus 44 squared divided by 8, right? You need to plug in the value into the formula, and the result of R. So either you can calculate by yourself or you can use calculator. Click on shift 1 and then you click on 5 regression. You study regression 5. You can see number 3 is R. So you click on 3, R equal to 0.952526 lah. 0.9526. Right? So you need to do exactly what I showing to you. So based on the value 0.9526, 0.9526 is a strong correlation, right? So when the value of R is between 0.75 and 1 is a strong correlation. Since this is a positive value, we can say that annual sales and annual advertising expenditure having a strong linear positive correlation. Or you can say that there is a strong linear positive correlation between annual sales and annual advertising expenditure, right? So this is how we calculate the Pearson product moment coefficient, right? So far, do you have any question? Can you comment any question, or do you understand? Please comment. Right, good. Alright, good. So we can move to the next topic, which is coefficient of determination. This is very simple, right? Coefficient of determination measure the proportion of variation. We measure the proportion of variation in y variable that can be explained by x variable, right? So means that the coefficient of determination is given by r power of 2, right? Coefficient of determination. So if the previous value of r is 0.95, so r squared is the coefficient of determination. This is a coefficient of right? So r squared is 0.95 power of 2, which is equal to 0.9025. So we express the value of coefficient of determination in percentage. So we need to multiply with 100%, so it becomes 90.25%, right? So this is the coefficient of determination, right? So let's say the value of 90.25 represent the variation, the total variation that explain why, dia kata sini, the variation of y can be explained by x by 90%. The variation of y can be explained by x is 90.25%, right? So we can say, otherwise we can say there are 90.25% of the variation in y is explained by x, right? So now let's look at example number 52. We need to compute the coefficient of determination using example number 49 and explain the meanings. So example number 49, this is example number 49. The coefficient of product moment, Pearson product moment is 0.95. So R is equal to 0.9526. So R squared is equal to 0.9526 power of 2. 0.9526 multiply power of 2 is 0.9074. 0.9074, which is also equal to 90.74%. So in this case, we can say that there are 90.74% of the variation in Y. Our Y is annual sales is explained by annual advertising expenditure. Right. Okay. So far, coefficient of determination. Do you understand? Any questions so far? So I think we can finish this chapter by today. Very simple, right? No question. Very good. So for the next topic, this is the last topic for today. Very short topic. Chapter number 4 is very short topic, right? So we move to the next topic, which is the last topic in chapter number 4. Simple linear regression. So simple linear regression is statistical techniques to estimate the best fit line to show relationship between dependent variable and independent variable. So the best fit line means, so once you construct a scatter diagram, right? A scatter diagram, we have x-axis and y-axis. This is y. X, let's say the data is look like this. So we want to estimate the best fitted line. The best fitted line should be, let's say, like this, either this one or this one or this one. So we want to estimate which line that fit to the data, right? So the line that we want to estimate should have the less error. Error means the difference between observed and the predicted value should be the minimum, right? So let's say this is the best line, right? So we want to establish the line that have a minimum error. The error means the fitted line, right? The predicted line, different between observation and predicted line. So the summation of the mean of the error should be the minimum amongst others predicted line, right? So this is also what we call as a regression line. So or the regression equation is based on this formula, y equal to a plus bx. If you still remember, y equal to mx plus c. So if you look at a regression equation, is a same equation. So this is a linear equation, right? That's why we want to draw a straight line, right? So since we are measuring linear correlation, so the best equation should be linear equation. So m is the slope between the line, right? The slope between the line, right? And c means the intercept of y axis, right? So in this case, a is the y-intercept and b is the slope of the line. So this is the regression equation. So y equal to a plus bx. So when you want to establish a regression line, right? So we want to get the equation of regression line. So now the value of A and B can be obtained by using the least square method. So the least square method is this formula. B is equal to summation of xy. So I make it bigger. Summation of xy minus summation of x summation of y divided by n divided by summation of x square minus summation of x and then u square divided by n. So this is the formula for B, right? So B, right? And A is equal to summation of y divided by n minus B multiplied with summation of x divided by n. So B is from here, right? So to calculate to establish the equation of linear regression, first the very important step is to identify the dependent variable and independent variable. If you wrongly identify the dependent variable and independent variable, you will get the wrong value of b, right? The value of b should be the value of b is should be uh, should be wrong lah, right? Right. So since b is the slope, right? Since b is the slope of the line y equal to a plus bx, so we can interpret b as every unit in x increase in x variable, y will also increase if b is positive. For example, let's say y equal to, let's say 2 plus 5x, right? For example. So this is actually B and this is actually A, right? So for every unit increase in X, right? Because B is a positive value, where for every unit increase in X, Y will also increase, right? So let's say you have another equation minus 5x. So for every unit increase in X, y will decrease by 5. For every unit increase in x, y will decrease by 5. So because we have negative 5. So this is positive 5. So means for positive 5, for every unit increase in x, y will increase by 5. Right. So now let's look at example number 53. So in example number 53, we want to know the relationship between the number of study hours in a week and GPA obtained by 10 students selected randomly from the class. So given the data below give the following result. So we have number of study hours and GPA. So now, the most important part. First, we need to identify what is the dependent variable and what is independent variable. So the number of study hours depend on GPA or GPA depend on number of study hours. Can you say something?
GPA depend on study hours.
Yeah, GPA depend on study hours. So GPA is dependent variable and number of study hours is independent variable. So this is very important step. You need to clearly identify what is the dependent variable and what is dependent variable. If you wrongly identify, then the following question you will get the wrong answer. Right? Right. Now, second question, we want to find regression equation of GPA based on the number of study hours. Right? So, let me sharing the whole screen. Right, boleh nampak kan? So now, we want to find regression equation, right? Regression equation is y equal to a plus bx. So this is a regression equation. So b is equal to summation of xy minus summation of x multiplied with summation of y divided by n. And this is divided by summation of x square minus summation of x square divided by n. Right. So of course, in this formula, we need to find the value of xy, summation of x, summation of y, and summation of x square, right? Right. So you can see my calculator. Boleh nampak calculator I kan? Right. So now we clear all the memory, right? Shift 9 3 equal AC. We clear all the memory. Click on mode, find 3 for statistics and find A plus BX. Number 2. Right. So same step as before. Right. So make sure you input the value in the correct column. Right. This is X, input into X column. Y, input into Y column. Right. So the first one is 9, 7, 10, 6, 7, 8. This is 12, 4, 5, and 6. So we have 10. So now I begin to input for Y, 3.2, 3. This is 3.15. 2.84. This is 2.98. This is 3.48. 2.01. 2.28. 2.90. Right? Oops, something wrong. So by using this calculator, you can recheck balik. So this is 3.2. 3.15. This is 2.84, 2.98, 3.05, and then 3.48, 2.01, 2.28, 2.90. So this is a special of using this calculator lah. Right. So you can recheck your input data imputation, right? So click on AC, click on Shift 1, 3 equal to sum. XY is 5 is equal to 222.2, right? Summation of Y, summation of X is equal to 74, and then summation of Y (28.89) and equal to 10. Summation of X square is 600. Right? You just plug in the value into the formula. Remember, just plug in the value into the formula. 222.2 If you not plug in the value into the formula, you just give me the answer, then we will not get any marks. 74, this is 28.89 divided by 10, everything divided by this is 600 minus 74 power of 2 over 10, right? So once you plug in the value into the formula, just go back to the calculator, click on shift 1 and find regression number 5, right? And then can see B is number 2. Click on 2 equal to B. So this is 0.1606. 0.1606. Right. So once you already calculate for B, then now we need to calculate for A. Right. Same step. A is equal to summation of y divided by n minus a plus B summation of y summation of x divided by n. Right? Is it? Minus, right? So you need to minus. So this one, summation of y is equal to 28.89 divided by 10. This is actually the mean of y, and this is 1.0160.6, and then this is summation of y and summation of x, 74 divided by 10, right? So go to the calculator again, click on shift 1, 5 and find A, number 1. So this one is 1.70, is it? Yeah. So the regression equation here should be, let me oops. Let me take out this one. What the perf? Right. So the regression equation, let me use another color. Y equal to A is 1.70, B is 0. B, since B is positive, plus 0.1606 x, where we know x is the number of study hours and y is GPA. So this is how we obtain the regression equation, right? So how to explain number 3? So how to explain regression equation and regression coefficient obtained in B? So A is equal to 1.70, B is equal to 0.1606. A, when x is equal to 0, y should be equal to 1.70. Means when a student did not study at all, right, the GPA should be 1.70, right? So for B, for every 1 hour study hour, 1 hour study, right? So the GPA will increase by 0.1606. Why increase? Because the B is positive. If the B is negative, the GPA will decrease by 0.16. Right? So from the regression equation, right, we can also know the relationship of the two variable. If B is positive, then we can say that the correlation between two variable is positive correlation, right? So this is question number 3, right? So interpretation of the regression coefficient. And number 4, so estimate GPA obtained by Amir if he studied for 11 hours. So X equal to 11 hours, and we want to know what is the value of Y. What is the estimate of Y? So Y equal to 1.70 plus 0.1606x. We just substitute Y and X into the equation. So Y equal to 1.70 plus 0.1606 multiplied with 11. So this one should be equal to 3.47. So the GPA of Amir should be 3.47 if he study for 11 hours. Right. So far, any question regarding the simple linear regression? We already finished a simple linear regression. But if you notice, in determining the correlation, right? So I only focus on scatter diagram and Pearson product moment correlation. Spearman rank coefficient or correlation, I tak sentuh because it will not be in your final exam, right? So far, for simple linear regression, any question so far? Question? No question, right? So since you have no question, I will post this lecture note into Google Classroom, right? Right after we finish the lecture, and then I leave for you a homework, tutorial number 4. This is just a homework, right? So you need to do by yourself question number 1 until question number 10. Sorry, question number 12. So we have 12 questions for you to do, right? So we will discuss this tomorrow, right? Make sure you do it by yourself first, and we will discuss this tomorrow, right? So far, before we end our session, do you have any question? Please, any question? So if you don't have any question, then I guess we should end our lecture by today. And by finishing a simple linear regression, we already finished chapter number 4, right? So we will continue on the next lecture. We will continue on chapter number 5, which is index number. All right. So then, Assalamualaikum.